Hello and welcome to today's SQL Office Hours session. And we'll start with a question which you may have been asked by your boss or colleague at some point, and that is to report time series events per hour. So you want to see in each hour how many things there were, or count or sum them, something like that. So we've gotten a report, something like this. So we've got the hour. There's probably a date over on the left of it as well. That's not really of interest here. We're more interested in the times. So it started at midnight. We've got 5 things, 1 a.m., there's 3 things, and so on. So in order to write a statement like this, what you would do is we could use the trunc function. So what this does is it rounds down the date time value to the specified unit. So HH means hours. So round it down to the hour, and then we can group by that and count and get what other figures that we want from that. So trunc supports most of the date format masks, so YYY, day, DY, and things like that. So we can round down to whatever units we want to. So this is fairly straightforward. But let's look at a slightly more complicated question. Rather than reporting per hour or per minute or something like that, what you've been asked to do is get a report of the event for every 5 minutes, so in 5-minute time slices. So basically, we've got 5-minute buckets. So we start at midnight and then go to 5 minutes past and then 10 minutes past and so on. Now, this is where things get a bit more interesting. It's like, well, how do we do that? It's not particularly obvious because there isn't, or there wasn't, a way to do this natively in the database. So that's what we're going to look at today. We're going to be looking at how we can group rows into n minute or n unit generally, hours. It could be days, hours, seconds, and that kind of thing, into multiples of the unit. So before we get into that, just to say, I'm going to be running this demo on Oracle Database 23AI free. This is version 23.7. Most recent patch for this is now available for that, so you can go and download that. So this is where the demo is going to be running. And we will need this to actually run some of the demos as well, because I'm going to be talking about some couple of new things in 23.7, which will help us actually answer this question. So before we do that, let's look at how we do it in the old days, or basically, I say the old days, basically all of us, right? And I don't think anyone's actually upgraded to 23.7 yet. How do we do this? So let's think about what we're doing here. What we want to do is get in 5-minute intervals. So we're going to call that the stride. So the stride is like the step, how far we are going each time. So 5 minutes each time. And we're going to start that from midnight on whatever date it is. So the size of the interval is the stride, and the starting time or the starting point is the origin. So those are kind of two key terms that we need to know here. So what have we got this time? 23 minutes and 45 seconds past 1 a.m. And we want to find the 5-minute start and end buckets for this. Well, the start time for that is 1 minute, 20 minutes past 1 in the morning, right? So the 5 round down to the 5 minutes. And if we want to find the end time, that is 1 a.m. 25 minutes past 1. So one thing to note, just a little detail here, is the buckets are less than and include these times, but it excludes the upper boundary, right? So anything up to but not including 0125 is in this bucket. Anything starting from 0120 is in that bucket. So how do we find these values? How do we find 0120 and 0125? Well, what we can do is essentially split the data up into buckets, numbered buckets, and then multiply them back up by the stride. So that is the time interval that we want to look in, so 5 minutes here. So let's look at how we do this. How do we find this information? Well, the first thing we're going to do is find the minutes since the origin. So 23 minutes past 1 a.m. 23:45 past midnight, subtract 1 from the other, and that is 83.75 minutes. We'll divide that down by 5 minutes, so that gives us 16.75, and then we're going to round that down to get the bucket. Okay, so we're in bucket 16, so we're on the 16th 5-minute interval after 1 a.m., essentially. So that is that kind of first thing I said we were going to point out here, find the bucket number. Then to turn that into the actual start time, we'll multiply it up by 5 minutes. So that gives us 80 minutes. Add 80 minutes onto midnight, and we get 20 minutes past 1 in the morning. So that's kind of the process we're going to go through here. So First step, we've got our date time. So this is probably a column in the table and our origin date value. Subtract one from the other. Then we'll divide it through by the stride. Take the floor of that to round it down. So this gives us the bucket number. Multiply it back up by the stride. So essentially we're kind of cancelling out the strides here to make it multiples of 5. And then add that to whatever our origin time is again. Add that origin time on again. So this gives us a start time for each bucket. So we're starting at 0120. What if we want the end as well? So we want 0125. Well, the process is pretty much exactly the same. Getting the start, getting the end of a bucket is actually the start of the next bucket, right? Because all the values are kind of consecutive here. So the process is almost identical. There's just one tiny little difference here. Is after rounding down, we want to add 1 to whatever our bucket number is. Because like I say, the start of one bucket is equal to the end of the previous bucket. Okay, so they kind of match up here, or the next bucket, depending on which way around you think about it. So we can use those to get those values. And in a formula, after doing the floor, we just add on 1 there. Okay, so that's kind of an overview of the process. And let's jump in. Let's start actually do this for real. Well, before we do that, there's actually a couple of little complications and things we might want to think about here. First up, we're saying we're taking the date time minus the origin, right? Now, if either of these values is a timestamp, the resulting difference is an interval, so data type interval. Okay, and I noticed someone was wondering why Oracle has not implemented division of 2 intervals. That's going to make this division operation a bit complicated here, right? So you can do this with intervals. The math is a bit more complicated though, because we have to turn those intervals into a number of minutes or a number of seconds or something like that. I'm going to assume that we're working with just dates, okay? If both these values are dates, then the difference is the number of days between them, okay? Now, if either of these values is a timestamp, to kind of simplify it, you could just cast them to dates beforehand if you want to, or if, it's a timestamp with time zone and you need to preserve that time zone information, you can extend the arithmetic a bit to actually handle the intervals. Like I say, that's adding more complexity, so I'm just going to assume we're working with dates for today. All right then, so we've got dates and we're going to get the difference in the number of dates. That's the number of days. So that makes things nice and easy, right? Well, there's actually a bit more of a subtle problem here that you might run into, and that is numeric imprecision, or floating point number imprecision. So what do I mean by that? Well, what's going on here? Well, let's say we take the time 15 minutes past 1 in the morning and take off midnight. So let's imagine these are in fact real dates, they're not just times. So the difference between these is 75 minutes. Okay, so it's in bucket 15. So we've got 5-minute intervals. We're in bucket 15. There's 75 minutes between them, divided by 5. That's 15. However, right, when we subtract this from that, the difference is the number of days between them. So to convert that into minutes, we need to multiply that up by how many minutes there are in a day. And there are 1,440 minutes in a day, so multiply that up, and we'll get a number like this. It's like 74.9999. Oh dear. Oh dear, oh dear, right? This isn't 15, okay? Or this isn't 75, I should say. And if we take the floor of that, if we round that down, you're actually going to end up in the wrong bucket. Ooh, okay. So you do need to do some rounding here to kind of avoid this problem. This is quite a subtle problem. It's easy to overlook. I must admit, I got halfway through building the demo of this before realizing I'd actually hit this. So, you need to be careful and watch for this when we've got these values. Well, we'll look at this in a bit more detail. So after subtracting one from the other, you multiply it up by the units in the day and then round the result. Now, you see I've rounded it to 9 decimal digits. You're like, why have I done that? Why haven't I just rounded it? Okay. Well, if we just do a normal round, anything which is at the half will get rounded up, which is not what we want, and you'll get incorrect values. Okay. Doesn't have to be 9 decimal digits, but I found that, 1 or 2 still actually rounds it the wrong way sometimes. So I just chose 9 to be safe. So the units in the day, there's 86,400 seconds in a day, 1,440 minutes, 24 hours in a day. So whichever of these units you're working with, you can use that. Now, you could just work with seconds and round everything to the second, so just a straightforward round. But then if you want 5 minutes, you need to convert 5 minutes into seconds, 300 seconds. Gets a bit more fiddly, a bit harder to think about. But it's up to you, right? You can do that if you want. I'm going to assume we always want to work in the units of the stride. So if I want a 10-second interval, I'm going to be working in seconds. If I want a 5-minute interval, I'm going to work in minutes, not seconds multiplied up to be minutes. Okay. So that's the overview of the formula. Let's actually jump into the demo, right? That's enough kind of gibbering about how it all works. Let's look at it actually in practice. So first thing to point out, like I say, I am running on 23.7, the most recent release of Oracle Database free. So you will need 23.7 if you want to use that. You can download the free version, as I say, or if you're running on Oracle Cloud, the always free tier, that is also on 23.7 available. And we've got a bunch of time data. It's just a table with one column, really. So sometimes after midnight. So various times in there. So start off with, if we just want to round to a whole unit, so the number of days, the number of months, the number of hours, whatever, like I say, we can just use the trunc function and we can, pass in various units to say what we are rounding to. So round to the year, that's the 1st of January this year. Round trunc to the month is the 1st of February. Trunc to the day, those dates were the 1st of February. We've got some which are the 2nd February somewhere further down. Round to the hour, you can see it's 4 a.m., 3 a.m., or we could round down to the minute. So whatever units we want. And then if we wanted to group by unit like that, so group by hour, we just group by the trunc. And in 23 AI, we can group by alias as well. So I don't need to duplicate this trunc expression all over the place. And it's nice if we decide we need to change the units. So, if I wanted to change that to minutes, count the things per minute, we can just change that there as well. So that's relatively straightforward if we want to group by one unit. But what do we want to group by n units? So 5 minutes, as I say. We want to find the number of units between the date time and the origin, divide that by n, so 5 for 5 minutes, round it down, take the floor, multiply that back up. So that effectively cancels out any fractional things and add that on to the origin. So let's break that down. Let's say we've got 12 minutes, 30 seconds past 12 a.m. No, 12 minutes and 30 seconds past 12 a.m. And subtract the day start off. You'll notice that the result is a fraction of a day, which is 0.0086. It's a bit of a fiddle to work with. So we multiply that up by the number of minutes in a day for 1,440, we get 12 and a half minutes. So if we want to then convert that into a bucket number, so looking at this, I think most of us can see that the start of the 5-minute interval for this would be 10 minutes past midnight. And that would be the second bucket, the second bucket that we've got here. So bucket 0 starts at midnight, bucket 1 starts at 5 minutes past, bucket 2 starts at 10 minutes past. So if we find the difference, turn it into minutes, and then divide by 5, we get 2.5. Take the floor of that to round it down, we get 2, the second bucket, turn that back into minutes, so multiply it back up. So just kind of breaking the steps out there. Now, as I said, we do need to be a bit careful when doing the subtraction here. If I'm finding I've got 20 seconds past midnight, so I want to find 20 seconds, or as I showed in the slides, like 15 minutes past 1 a.m., 75 minutes. If we multiply those up, they are not the exact value that we are looking for. Okay, we want this to be 20, right? Not 19.99999. And we want this to be 75, not 74.9999. Because if we round these down, we take the floor of them, you're going to be in the wrong bucket. They're going to be in the previous time slice. So that's a bit of a problem. So as I say, we want to round the result of that. So let's start bring this all together in a bit more detail. So I've just got a subquery at the start to kind of select the values. So we're going to start at the beginning of the day. say the number of minutes in the day, and our stride. So first up, I'm going to kind of break these out and just show how they work. So we've got, you see, I've got the wrong bucket here as well. I'm rounding that to show what it should do. And I've got it without rounding it to show what will happen if we don't round these values in some situations. So in most cases, wrong bucket and bucket are the same. But if I scroll down and I find 115, you can see this is going in bucket 14, not bucket 15. So we do need to do this kind of rounding to make sure it's in the right place, because they say we've got this floating point imprecision here. So this gives us our buckets, our correct buckets. We then just multiply that up by the size of the stride and add it to the origin. So we've got a second subquery like this, or second common table expression. So we've got our bucket number here. Take the origin, add it on. There's our start. If we want the end, it's just the start of the next one. So it's bucket plus one, right? And then we go and run that, group by, and we can see we've got everything in our 5-minute intervals. So midnight to 5 minutes past, 5 minutes past to 10 minutes past, 10 to 15. We actually have a little gap here. There is no data for 15 minutes past to 20 minutes past. So we go from 20 onwards. So that was kind of the basic process we've got here to do this. Now, a couple of things you might be wondering about is what value to choose for this origin. And the answer is it kind of doesn't matter as long as it is a valid start bucket time. If we can continue these buckets on, these intervals on either as far back in the past or far forward in the future forever, as long as the value you choose for the origin would be on that line somewhere, it actually doesn't matter what it is. We've got like the end of time in Oracle database, the 31st of December 99. It's midnight, so the buckets will still just work, right? The maths just falls out, right? It's just mathematical operations. So as long as this value would be the start interval somewhere, you're fine. Usually that's going to be midnight. Generally speaking, we want to start at midnight or on the hour. So just the start of the day. But if you do want to use a slightly different time, just be aware of that. Just make sure it is a valid start time, a valid start bucket time. We'll look at that a bit more in a second. So we've got this, and one of the things we can do, we can actually then, we've got our structure here, we can make this a bit more generic, and it will work for kind of any unit that we want to multiply of days or smaller. So minutes, seconds, hours, or even days, right? So if we run this, and I've got some bind variables to kind of make it generic. So we'll start 1st of February at midnight. Units in the day, we want minutes, 1400 and 5 minutes. So let's just apply that. And that's what we had a second ago, right? But I can also change that. Let's say I want that. So 24 hours in a day, I want to get that in every 2 hours, for example. We can just change that. And you can see we're going up from midnight to 2 a.m. to 4 a.m. to 6 a.m. and so on. If I wanted seconds, I could go 6,400 and say every 5 seconds. There we go. So we haven't got that many per second or for every 5-second thing that we wanted. And I could also have like a non-standard interval start. So 2 minutes and 30 seconds will be the start time. So everything will be slightly offset here. So I'll go 5-minute intervals starting at 2 minutes and 30 seconds past midnight. So you can see the first values fall in the bucket before because they were in the first minute. So their start time was actually before midnight the previous day, or 11 p.m. the previous day. And you can see everything there is the 2s and the 7s, 8 minutes, seconds. Right. Any questions or comments on that before we move on? I appreciate there's kind of a lot of kind of maths and formulas I'm throwing at you there. So let me know if you've got any questions or comments on that before we move on. Yeah, just come back to the question about intervals. Unfortunately, you cannot divide an interval by an interval. So when we've got these like dividing by the stride, if we made this an interval, it doesn't work. You have to convert that into a number. Why that hasn't been done, I don't know. Maybe it will be one day. All right. So time interval could be hour and minute. So I guess you mean what? I mean, if you want it to be multiple of things, so let's say 1 hour, 15 minutes, right? We'll just convert that down to minutes. Okay. So 1 hour and 15 minutes is 75 minutes. So we just work in minutes still, but say it's 75 of those. And now we are going in, let's do it at let's do it starting at midnight. It's a bit easier to see what's going on there, right? So we're going from from midnight to 1:15 to 2:30 to 3:45 and so on. So if you want to cross multiple units, just multiply, just work in whatever the smallest unit is. So, one and a half hours, 1 hour 30 is 90 minutes, for example, or so convert to the smallest unit and just work in multiples of that if you want to work that way. Again, the formula works here as long as we stay within days or smaller. You cannot cross days to months because months are not a standard time unit, right? So we'll look at months in a little bit. Okay, so let's just kind of recap on that. So we want to write a formula to place values in a bucket into n unit intervals. We find which bucket fraction they go in, take the date time we're interested in, minus our origin date. So it can be any value which is a valid start bucket time, and divide it by the stride. Things to be aware of: if either of these dates we are working with here is a timestamp, the result is an interval, and you need to think about the maths for that, converting that. The simple approach is just to cast everything to a date beforehand. The alternative is you've got to do some extraction of the interval and convert that into a number of minutes or seconds or whatever. However, when you are working with days, there's floating point imprecision, and you can end up just ever so slightly out for some of these. So you need to make sure you're rounding the result as appropriate. So that gives us our fraction, turn that into a bucket number. The start of the bucket, the start time, just round down, take the floor. The end is the floor plus 1. And then to turn that into the bucket start time or the bucket start or end time, take the origin, add to that this bucket value number we've calculated and multiply it by the stride, the time interval that we are working with. Okay, so that was quite a lot, right? So at this point, some of you are probably scratching your head a bit and going, oh, that's a bit fiddly, that's a bit funky. I don't want to have to remember all that, right? Plus, as I said, there's a bit of a problem here if we want to work in units bigger than a day. I mean, we can do weeks because a week is just 7 days. But if you want to work in months or years, so group everything into 2-month intervals, for example, this approach won't work. I mean, conceptually it works, but we need to do a lot more complicated logic to make sure we're converting things to the correct bucket, because a month is not a fixed duration. It varies from 28 days to 31 days. So the logic there gets quite gnarly, or can certainly do. So fortunately, in 23.7, and the whole reason I'm showing you on the latest release is there is a new function, time buckets, which does this all for us. So how does time bucket work? Well, it's got the function name, time bucket, date time, the value we want to find the start or the end points for, the stride, what our n minute interval is or n unit interval is, and our origin date time. Again, like I say, that's any value which is a valid bucket start. There is an optional fourth argument to say whether this returns the start or the end of the bucket. By default, it's the start. So we can do something like this. We can time bucket a column and do 2-hour intervals starting from midnight on the 1st of February. So here we can now actually use an interval stride. So before we couldn't do that. We had to work in multiples of the unit. Here we can actually have interval values to specify those, and say we're calculating those from midnight. So if we wanted the logic we had before to group everything into 5-minute intervals, we do something like this. We have our time bucket, start time, interval 5 minutes, and then optionally we can specify start as well to get the start date. To get the end date, we just say end, and we group by the result of that. And that's it, right? We don't need to worry about any formulas or rounding logic or things like that. So this is much simpler, but as I say, it also allows us to work in different time units. Let's say we wanted to report the events per quarter, so every 3 months. Well, we can just pass in interval 3 month and it just works, right? We don't have to worry about normalizing everything to months. It's also got a few other little tricks up its sleeve as well. So one of these is working with epochs. So if you're not familiar, epochs are the number of seconds since the 1st of January 1970, which was chosen as the dawn of time for computing, right? So what we can do is we can have time bucket. So the epoch 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 is the 13th of February in 2009. So 23, 31, 30. We can use this to get that epoch start as a number. So 0 is just our first, the very start, midnight. So we're working today. We know that's valid start. And that allows us to work with epochs as well. Again, if in theory, we could do that with the previous, well, we could do that with the previous formula, but then you need to figure out how to convert these epochs into actual dates as well, which is an added complication. So we can do that. So we've got some flexibility there. There's another question that might come in, and that is, how do we bind the interval? So previously with our formula, it was just a number we were working with, the number of the units. But now you can see I had an interval literal, interval 5 minutes, interval 2 hour, and that kind of thing. Question is, well, how do we bind that as well? You know, if we want to make this dynamic to allow users to specify custom groupings, so change between 5 minutes and 10 minutes and so on, how do we bind that? Well, if we know which units we're working with and we're staying either days or smaller or just years and months, we can use these num to ds, num to interval functions, num to ds interval. So n, so it would be 5, and units, and that would actually be the word minute if we wanted 5 minutes. So the key thing to note here is we need to know whether we're working in days to seconds, days or smaller, or years or months. If we don't know, then we need a kind of case expression to choose between them and some kind of flag to do that. Fortunately, there is actually a simpler way. We can actually pass in an ISO, an 8601 ISO time interval duration. So this is a string format. So those of you who are familiar with these ISO standard things, it's exactly the same format for a time. They start with a P, and then they have the number of units. So notice I've got PT5M. That T is quite important because that specifies it's a time. If we exclude that P5M is 5 months. Very simple little thing to miss here. You mix up 5 minutes and 5 months, and you can end up with completely different results, right? So just pay attention, be careful there. However, because this is just a string now, we can bind in any value, right? We can now pass in 5 minutes, 5 months, 3 years, whatever. We can just bind this value. However, that said, we still can't mix values which are across units from days to months. So if we had P5M, T5M, so 5 minutes and 5 months, it's going to ignore the minutes and just round to the months. So we've got months or years, it's only going to round to those. If we want minutes and smaller, or days or smaller, I should say, you specify just those. So we can't cross that boundary, but we can specify either in one thing. So nice little way to kind of make this work for whatever time unit that we want to do and make it fully dynamic. So this is good, but it's still kind of quite computationally expensive. It still has to do quite a lot of work. I mean, this is done in the native database stuff now, but it still, you know, has to divide. Essentially, it's doing something very similar to that formula I showed you under the covers, right? Which is quite computationally expensive. So the question is, well, how can we make this faster? How can we speed it up? Now, the obvious way is to kind of create an index on it. But that's only going to help if the query is going to use the index. If we're specifying, you know, selecting a large enough time frame of our, or large enough fraction of our data that the query is going to do a full table scan, that index doesn't help us. So what can we do there? Well, there's something else new in 23.7. We can add a calculated column. So we've got 5 minute group here with our time bucket. Notice there's this new materialize keyword for these column expressions in 23.7. That means store the result on write. So when you insert or update the value, I'll actually store the result of this calculation. So it means that runtime is just fetching the result. So this is a lot like virtual columns, if you're familiar with them. Virtual columns have been around for a very long time. We can have that column, which is the expression. The difference is virtual columns are calculated on read. So every time we select it, we still run the function. With materialized columns, we calculate it on write. So when we insert or update, but when we query, we've got the result, which in some cases could lead to good kind of performance gains. So that's enough kind of slides again. Let's jump into a demo and look at that, how this all works in detail and a bit more practice. So first up, let's just do time bucket on its own, standalone. And I'm going to have some timestamps. So one of the other things you notice here is this now just works with timestamps. Like say the formula we had before, it can work with timestamps, but we need to do a bit more massaging of the values of the intervals. Here, this just works with timestamps. So we got messing the thing up there, scrolling off the screen. So that time we saw it, 1 a.m., 23 minutes, 45 seconds, put it in a 5-minute bucket starting from midnight. And we got the start and the end. So we run those and we get 20 minutes past 1 and 25 minutes past 1. Exactly what we'd expect. Hey, fantastic. So we can now use that. And you remember that code we had before, which was pretty much a screen worth of code. We've simplified it down to just a few lines to find the start and end buckets. And this is what we had before. So we're going from midnight to 5 minutes past, 5 minutes past to 10 minutes past, so on and so forth. We can also, as I say, then it just works for intervals of 2 months. So we're going to go from the start of the year and make these 2 monthly intervals. So we've got January and March. So add 2 months on the 1st of January, you get the 1st of March. Okay. So it works for year-month intervals by default, add box as well. We don't need to do anything special. We can also do it with epochs. So here's our epoch, and that's our number here, which I trust is the 13th of midnight on the 13th of February. I don't know. I'm not an expert in epochs. I don't think any of us really know these, except maybe some of these special ones. You might remember what these are, but otherwise they're a bit indecipherable to us people. Right. So, but what I'm saying, we wanted to bind this. If we wanted to say what change the duration, the interval that we are working with. Unfortunately, this is an interval literal, so you can't bind this value here. We'll try and run this, and it'll go, you can't do that. Invalid a number of arguments. We'll get an error. The way to avoid that is to use num to ds interval. So we have n and our unit. So here we're saying it's a 5 minute. Run that, and we've got sys_state. So what time are we? We're just kind of 2:33 in the afternoon. So we've gone rounded down to 2:30. This does a job, but like I say, you need to know whether you're working with days or smaller or years or months, right? And choose appropriately. So still a bit of thinking and choosing you need to do there. We can simplify that by just passing these as ISO time intervals. So like I say, P5M is 5 months, PT5M is 5 minutes, P5M T5M is 5 months and 5 minutes. However, for time bucket, it ignores the minutes. It will only round to the months. Okay, so just be aware of that if you cross these intervals. So let's just do this. Let's look at that. So we've got P5M. Notice I have missed the T. So we go to the 1st of November. So I've set 1st of January 2024, so a year ago. So we go 1st of January, and then 5 months after that was that the 1st of May, 1st of November, and then that would take us to the 1st of March as well, I think, or something like that. I can't remember now. So we can see that's rounding to 5 months. If we stick the T in there, it might be a bit tricky for you to see it from the top right here, but I'm sticking a little T in here. We're now doing what we kind of probably hoped or wanted to do, which was round to the 5 minutes. And you see there we've got our 5 minute intervals like that. And as I say, if we mix and match these, so we got 5 minutes and T5M, it will only round to the months. So we went 5 minutes. If it was 5 months and 5 minutes, you'd think, okay, 1st of January, midnight, and then 5 minutes past the 1st of May, 10 minutes past the 1st of November. No, it's still midnight because it's ignored the time component here. But again, we can do this. So we can use this, but we can also use it to do hours as well. Someone was asking about mixing hours and things like that. If we wanted to do, I think it's H. Now. Hopefully it's H. We can do 1 hour and 5 minutes. Let's do an hour and 15 minutes, actually. We can actually combine those. Yeah, so we can see if we want to go multiple things like 1 hour and 5 minutes or 5 minutes and 5 seconds, something like that, we can combine those like that. And you use the interval, those values there. So, okay, so far we've always known what our origin was, or we know what a valid bucket start was. We may not always know that, right? Sometimes you might want to choose that from the data. So whatever the lowest date is, that is the start, right? So we can do that. One way we can do that is to just use this analytic to find the min in the origin date and then pass that in. So we're going to find the smallest time as our origin. Again, we're going to go 5 minute intervals as well. And you can see it goes 01, starts 01, 11 seconds past 1 a.m., then 6 minutes, 11 minutes, but they're all on the 11 seconds, so we use this value as a start date here. So we want to pull it from the database, we can do that. See if questions come in saying, I think asking about the 29th of February. So it won't cause a problem, or it shouldn't cause a problem. Let's just see, how does that, I can't remember exactly what it does do. So last year was leap year, so we can pass in 29th of February. So we can use that. I forget exactly how the logic for it works off the top of my head. If you stick around at the end, we could probably just double check how it works, but it will work. It's not going to throw an error like it does with other intervals, which is a problem if you add and when you're working, adding and subtracting intervals normally. Actually, let me check that. Let's check that quickly while I'm talking. Let's do this one here. Let's change this to this one. Let's check this quickly. Let me not just assert things. And let's say for 1 month to 129. Actually, no, I'll come back to that later because I need to think a bit more about what we're going to do. So we'll see if we've got time later. We'll come back to that. All right, let's look at these virtual versus materialized. So I say virtual columns have been around for really long, over a decade now, really long time, and they are calculated on read. Materialized new in 23.7, calculate on write. So when we add these columns, the result of this is now stored in the table. This is still going to be calculated at runtime. So we've done that, and we can simplify things even further if we want to do here. So we can see we've got a result, so we don't even need to remember it's a time bucket function, right? Notice if we've got other intervals we want to work with as well, we could potentially add more of these, so 5 minute, 10 minute, 15 minute intervals if you've got common ones that you're going to work with. Now, does that actually really make a difference? Is probably one question you're asking. So let's see. So I've got the materialized, storing the results. I've got the virtual column, which is calculating, and I'm running calling the actual function as well. And you can see they've run away. So the stored result, so this is hundredths of a second. So this is about 0.2 of a second for the stored result, whereas about 6 seconds for the virtual time bucket. These two things are essentially the same thing. So you'd expect them to give basically the same time. You can see storing it can make queries a lot faster. Just do bear in mind, you've shifted that work from reading to writing. So if you're write heavy intensive, there's a trade-off to be aware of there. All right. Any other questions or comments before we move on? We'll come back to the 29th of February later because I need to think about how the demo will work a bit on that. But any other questions or comments on that before we move on? No, okay. I'm not seeing any other things at the moment. So let's just recap on that. They say time bucket, new in 23.7, and that allows us to work with any any intervals we want, days to seconds, years to months, and just specify the start or the end as a keyword. We can use different units for this as well. We can it actually supports epochs as well, which is something we don't have. I don't think any other functions in Oracle database support epochs. And we can use ISO time intervals for the stride. So it's very useful for kind of binding what that value is if we want to make that a bit more dynamic. And then when it comes to performance, they say, if we want to make this dynamic and change things, we should use bind variables. We can bind those ISO intervals. If we're going to be running this calculation a lot and an index isn't going to be helpful, we can materialize the result. And this actually, materializing the result applies to any calculation, any calculated value you are going to run repeatedly on data. So this isn't just about time bucket. This materialized is for any calculated value you want to store, and you want to make sure it stays in sync with the data. Can you use a deterministic function with materialized columns? What do you mean a deterministic function? I mean, it has to be a deterministic function. I'm not sure what you're asking there. Yeah, could you be a bit clearer, and we'll kind of come back to that. Alrighty then. So we've looked at the formula, we've looked at time bucket. Let's look at some other kind of things, some more kind of unusual, non-standard things we might want to look at. And first of these is actually quite a standard thing that you might want to do, and that's include missing time intervals, right? So as we saw, if you remember, when we started with 5-minute intervals, we actually had a gap, okay? And quite often, you probably want to include that gap in your results, okay? And neither the formula or time bucket will help you here because they just work on the values on that particular row. So, for example, we've got our 5-minute bucket. Nothing happened in the bucket or interval midnight 10 to midnight 15, right? So there's no events there. How do we include that? Well, here we can use a slightly different approach. So we can list all the intervals, so we can generate them, or we can have a table with all the valid interval values in, kind of up to you, but we need a result set with all the starts and end times that we want. We can then join in our actual data, so outer join in our data that falls in between those start and end times, and then group by those and sort them, okay? So this allows us to kind of include missing time intervals. So if we want to generate them, we can do connect by level. So here's the number of buckets we want to have. So we want 5-minute intervals for the full day. It'd be 1440 divided by 5, 288. So that would give us every 5-minute bucket in the day. So we've got our intervals, and then we can outer join in those. Now, remember, it's an outer join. And we want to count the outer joined rows, we need to count a column from our time data, not count star. Otherwise, that will return 1 instead of 0. Okay, just thing to remember there. So that's probably quite a common use case. You might go, well, this is actually fairly simple SQL that works everywhere, basically everywhere, right? Anything where you can generate that source data. Why don't we do this? Well, relatively speaking, it's going to be quite expensive. We need to join in, generate our data or get our data and then join it in. It's going to be more efficient to just look at our data and actually get it. So if we know there's no gaps, or we don't care if there's gaps, it's going to be more efficient to just use time buckets or the formula. This is if you need to make sure that those gaps, or you need something that's just a bit more generic. All right. So let's move on and look at some more kind of non-standard or alternate approaches that you might want to do. One is where the groups all start from the first date in it. What does that mean? What do I mean by that? Well, let's work through an example. So we're going to start at 11 minutes past 1 in the morning. So that bucket starts at 11 minutes past 1 in the morning, and it runs to 6 minutes past. So 5-minute intervals. So the next one, it's 1 minute 23, that's in that bucket. 2 minutes, that's also in that bucket. Next minute is 6 minutes 46, is after 6:11, so it's a new group. However, the new group, the start time of the new group isn't 5 minutes. There's not fixed 5 minute gaps. We're finding everything within 5 minutes of the start, and then the new group starts at whatever that new start date is. So the gaps between the groups could be any size, right? It's just whatever the next value is there. So that's interesting, and so on and so forth. So how do we do this? So we can do this using pattern matching. I'm not going to really go into too much detail of this. If you really want to know more, we talked about visualizing SQL pattern matching a couple of years ago now. Catch the recording on that. But this is just kind of show you that this is possible. Basically, we're finding everything where the start date time is within the stride. So 5 minutes of the date time is within 5 minutes of the start. We could do something similar-ish, but different. Any group together all rows as long as it is within 5 minutes of the previous. So as soon as two rows have more than a 5 minute gap, they form a new group. So what does that mean? Right, let's look at our example again. So first group, start off, we go 01 to 06. The next time, 0123 is within that end time. But we're now adding 5 minutes. The end time is 5 minutes from this next row, because there is not a gap of more than 5 minutes between them, and so on. So this group now runs till 7 minutes past. This value falls inside it. Now there is more than 5 minutes between 6 minutes past and 13 minutes past. Now this forms a new group. Okay, so how do we do this? Well, again, pattern matching saves the day here. Here we're checking that they're within 5 minutes of the previous row. Again, getting into pattern matching is a whole big topic in its own thing. Check out the recording if you want to know more details on that. But let's just look at these demos kind of quickly. All right, so let's see where we want to generate every time interval. So we're going to get our number of buckets. So 5 minute intervals for a whole day, 288. So here are all our buckets for a whole day. Let's scroll down. We go to midnight on the 2nd from the 1st. We're then going to outer join our time data where it's between, less than or equal to the start, or greater than or equal to the start, but strictly less than the end. It does not includes the start time, but excludes the end time. Okay, and we can do that and join that in. Again, notice I'm counting the column, right, that we are outer joining to, not count star. So now we have our missing time interval. And like I say, you could use, I mean, if you didn't care, if you wanted about in the time things as well, this is another way to solve it, even if you don't care about the missing intervals. So we just turn it into an inner join. You can see we're now going 10 minutes to 15 minutes and then a gap there. But generally, this is going to be less efficient than using time bucket or a formula, because we've got to join and include these values in there as well. So it is another approach you could use though. All right, let's look at that match recognize, pattern matching. And yeah, we can see we want to group these into 5 minute intervals of the previous. So we've got 1 minute 11 to 6 minutes 11, then 6 minutes 46, 11 minutes 46. So each group is 5 minutes. It's still 5 minutes big, but the gaps between them vary. Or we just want to include everything that is within 5 minutes of the previous, right? And here we don't know how big the groups are going to be. There could be many minutes in them, and we don't know how big the gap's going to be between them either, right? So we can see this first group actually is from 1 minute past to 19 minutes past. And then we go to 20 minutes past to 37, and so on. Probably helps to see all rows per match for that one, see what's going on there. You can see the end date keeps increasing because all of these, the time is within that previous end date there. So as I say, if you want to know more about pattern matching, this is just kind of get you thinking about alternative ways of doing this. Check out the recording, and we could always have a recap and catch up on that another day if those of you care or interested. All right. Any questions or comments? So going back to that deterministic function with materialized columns. So I guess you mean your PL/SQL function a determinist, you mean like this, create or replace. I mean, yeah, I mean, as far as I know, it'll work, right? And I'm pretty sure it has to be deterministic, right? Um, let's just check, and let's do return p plus 1. We've got our function. Oh, helps if I give the function a name, right? Function f. And then we can do, let's just do datetime, materialize. Hopefully I've got that right there. Let's check. So I'm missing something there. Have I not lined up my like that. Let's try that. There you go. So yeah, it works, right? It's basically they are the same as virtual columns. It just stores the results. So virtual columns will calculate on read, materialize, calculate on write. Otherwise, it's the same principle, right? As far as I know, everything else is the same about them. And I'm pretty sure it does, in fact, have to be a deterministic function, right? If it's non-deterministic, then it won't work, right? So let's just and missing drop column in. Yeah, let's remove that. And we remove the deterministic keyword, right? So, and now we do it. Function is not deterministic. It has to be a deterministic function, same as virtual columns. And it just trusts that deterministic keyword that it is in fact deterministic. You can stick that in for non-deterministic functions. At that point, kind of all bets are off and weird things can happen. So don't do that. But just be aware of that. Okay. So let's just look at, so we do actually, so let's look at our time date again. Let's look at February, 1st of February. We've got a bit of time still, I think. So if anyone's got other questions or comments, so we do time bucket. So we've got values up to, let's see. Let us add insert into time data. 401, so the end of I need to got the functions I've added and time data. So we add that in. So if we add an interval to that, we're going to get an error. Select time date. No, time data isn't a value, right? It's date time. Let's see. We'll do this. I'll get there eventually. Right, we've inserted that. Select date time plus interval. Data. This will throw an error if we do it forwarding by. This is going to throw an error. Date, because it's going to add 1 month to that, try and get the 31st of February, which obviously doesn't exist. Okay. So if we do have time date 2024, 131. So that then does work and goes to the end of February. Is this? Hang on. What's going on there? It's why is it not included? That first one. Order by 1. Just do order by 1, right? Yeah. So it's found the end. But I guess it means, what do you mean by work, right? What do you expect to happen with the end of February? What do you think working means? Okay. I mean, it work, but what What do you think that means exactly? Okay. Um, what is working for you when it comes to the 29th of February? That's probably a better way to ask this question. Alrighty then. So let's just recap this and finish up. Okay, grouping rows into equal intervals. Or that's not unequal intervals, that probably should say. Should have fixed my slides. So one of the things we might want to do, the first examples we looked at with a formula or time bucket, if there was missing values and an interval with no data, it wouldn't be included in the results. If you want it, you've got to generate or have some data source with all the buckets and then outer join your data into that. Okay. You could use this as well if you even if you know all the values are there, but joining is going to be slower than just running time bucket or the function generally. If we want to have a variable gap between these buckets, they're a fixed size, but the gaps between them are variable. We can use match recognize. And if we want to vary both the size of each group and the gap between them, we just want to make sure they're within n units or minutes or whatever of the previous. We can use pattern matching as well. Let's recap all that. Placing rows into time minute intervals. If you just want to group by a unit, so year, month, day, hour, minute, you can trunk down to the unit for the format mask for the unit, group by that, does the job, and done the job for years, forever. Pretty straightforward. Challenge comes when you want to group in n units, so 5 seconds, 10 minutes, 3 days, that kind of thing. This is where things get a bit more interesting. I say olden times, but I mean now, really, right? Now you need to use a formula, but from now you can also use time bucket as well as a nice built-in way in the database to actually group these values. And if you've got some more interesting or challenging ways to do it, if you want to have the missing data, you need to out and join, or if you've got more esoteric requirements, you can use pattern matching as well. All right. Just to say, if you want to know more about, practice your SQL skills, learn Oracle SQL syntax and so on, we've got Squizzle, our daily guess the SQL statement quiz on Oracle Dev Gym. New one every day. See if you can guess it and try and figure out what the answer. If you want to learn SQL more generally, you're looking for a structured path, you're a beginner getting started. We have databases for developers, which takes you straight from learning how to create tables, write queries, run DML on them as well. It's completely free. Sign up and run that on Oracle Dev Gym. If you want to know, a quick summary of what's going on, we've talked about today. Here's a quick cheat sheet summarizing those. And let's just see, is there any final questions or comments before we wrap up and say goodbye? I'll leave this on the screen for a second or two so you can take a screenshot. Like I say, the recording will be available sometime later this week. And this is available on the blog as well, so you check that out. Alrighty then. Not seeing any other questions or comments, so all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something, and I hope to see you again in 4 weeks where we'll be talking about some more SQL. All right then, goodbye, enjoy yourself, and hopefully find somewhere a bit warm to kind of chill out. All right, goodbye.